For the question 1, collect the definitions and simple properties of example of stochastic process. For the first one, Poisson process. The Poisson process has the property of these three, and the first order probability mass function is this one, and the mean is this one, and the correlation is this one and this one. And for the Poisson process, the mean of a Poisson process is lambda t, that is a linear function of lambda, which can be understood as the longer in a time interval, the bigger of expectation of an event that will happen. And then for the second one, the Poisson increments, it has the property like this: the yt, and the first order mass function, the mean, the autocorrelation, and the autocovariance. This is related to the impulse of Poisson process. The expression of the correlation is a triangle with lambda t and independent to mu. If mu goes to 0, it becomes an impulse for the Poisson increment process. And then for the third one, the Poisson impulse. It has these properties. The zt is derivative of this one, and here is the Poisson. The mean is lambda, and the autocorrelation is this one, and the autocovariance is this one. And this has 0 mean, and the autocorrelation T1, T2 is equal to lambda, impulse of T1, T2, and the zt minus lambda is a white noise, and it is known as the short noise. And the fourth one, the semi-random telegraph signal. So the semi-random telegraph signal has these properties. It's the function in this form, and the mean is e minus 2 lambda t, and the autocorrelation is T1, T2 is equal to this one, and the autocovariance is this one. The pxt equal to 1 is higher than 1 over 2, and if the t goes to infinity, it will get close to 1 over 2, which matches the expectation that when it goes to infinity, the chance is goes close to the 1 over 2, and the ext goes to 0 if t goes to infinity, which also matches the expectation, because that means the t1, t2 goes to infinity, since that means they are going to far away. So this one goes to the 0, the mean. Like the distribution of 1 and minus 1 equals infinity, the distribution is evenly to 1 and minus 1. Therefore, the mean is 0. And then for the fifth one, the random telegraph signal. It has these properties. Like this one, and this is a strict sense stationary. And then for the sixth one, the random walk. So the random walk has these properties. The function, the first order mass probability mass, the mean is 0, and the T1, T2 is equal to the minimum of n2 multiplies s to the power of 2. And the T1, T2 is equal to minimum of n and m multiplies to s multiplies to the power of 2. When the n goes to infinity, we have Gaussian density according to the probability mass, and the autocorrelation function has the term minimum of T1, T2 that is coming from probability of independent increments. And then for the last one, the Wiener process. It has these properties, and furthermore, it has the following properties. Thank you.